Hi there, it's Professor McDonald. In this video, I'm going to show you how to answer this question, asking us to match each scatter plot shown below with one of the four possible correlations that are listed here. So let's get started with just introducing ourselves to the concept of linear regression and correlation. Linear is not the only type of correlation, but we will focus on linear. And linear means line. There are other types, such as an exponential pattern or a quadratic pattern, and others. The one we're really interested in for this course is linear. You may have learned about equations of lines in an algebra class when you learned about y equals mx plus b, the slope-intercept form of a line. And in this class, we'll be seeing something similar for linear regression lines that look like this, where you have the y-intercept first as b sub 0, or sometimes noted as a, or the slope instead of m will be b sub 1, or the letter b. Now, before we get into how we come up with an equation to model a pattern of dots that are plotted, these would be xy coordinates that were collected from a population. For instance, you could collect shoe size and height from a bunch of different people and plot them on an xy coordinate. The shoe size might be on the horizontal axis while the height would be on the vertical axis. There's lots of different types of information that would be paired. And once you get the dots plotted out, you might see a pattern. And if it's linear, then we can measure the linear strength and see if we can come up with enough strength, or see if there is enough strength to make a line out of it, a line equation that we can use for predictions. Now, before we actually get that equation, we're interested in whether or not the relationship has enough strength, enough of a line pattern. And that pattern could be uphill from left to right with a positive slope. It could be flat like this with no real slope to it, or it could be downhill like this. Now, if you can remember from algebra, when a line went uphill from left to right, it had a positive slope, and when it went downhill from left to right, it had a negative slope. And our correlation strength is measured by this letter called the correlation coefficient, R. Now, R just measures the strength. It's not the slope, but it's related to the slope in that they both have the same sign, and the slope is used when you calculate R. We let those calculations be done for us usually. We do have a lesson where we learn how to calculate R using Excel. But for the most part, what you want to know is how to read your R's. So if it's close to -1, it'll be, or rather if it's close to +1, it'll be an uphill slope. If it's close to -1, it'll be a downhill slope. And the closer that R value is to neutral, 0 in the middle, the less of a pattern strength you'll see. So when we look at these different options here, we can see that the first one has a very loose pattern. There's not much of a line pattern to it. So I expect that linear correlation coefficient to be very close to 0. And it looks kind of downward to me, so I'm thinking it'll be negative as well. So my best guess out of these choices is B, because it's very close to 0 and it's negative. The next one has a very strong looking pattern to it, downhill from left to right. So I'm looking for something that has a value that's very close to -1. So that would be A. And for this one, again, we see not much of a linear pattern, but it does look slightly upward from left to right. So I would look for a small value that's positive. So D looks like the best option there. And for this one, I see a stronger linear correlation, and it is from left to right, so it would be positive. So I'm looking for a positive value that's closer to 1, and that would be C. And there you have it.